There is apparently a crisis in scientific peer review. Researchers receive more review requests than they can reasonably handle, so they decline them. Editors struggle to find reviewers, papers can sit in editorial systems for months. Some can even be rejected because the journals simply fail to find people willing to review them. That happened to me. And everyone agrees that something has to be done. Which is interesting, because peer review is one of those systems that probably should never have worked in the first place. A scientist spends several years doing research. They write papers, they send it to a journal. The journal then finds 2 or 3 other scientists and asks them to spend several hours checking it, for free. These scientists usually have no contract with the journal, they may never have met the editor, they have absolutely no financial interest in completing the work, and their reward is generally an automated email saying, "Thank you, we appreciate your time." Sometimes there is a certificate, which is useful if you happen to have a wall with unusually large amount of empty space, and yet for decades this strange arrangement worked reasonably well. For anyone outside academia, here is roughly how the peer review works. You send your research paper to a journal. An editor first decides whether the paper is potentially interesting publishing. If it survives that step, the editor sends it to reviewers, the experts working in roughly the same area. The reviewers check whether the experiments make sense, whether the statistics is reasonable, whether the conclusions are actually supported, and inevitably whether the authors have failed to cite the reviewers' own paper. They send comments back, the authors revise the manuscript, sometimes they perform additional experiments, sometimes the reviewer asks an additional experiment that would require approximately 3 years, 12 genetically modified mouse strains and medium-sized particle accelerator. The authors politely explain why this is not possible. And after 1 or more rounds, the editor makes a decision, accept or reject. This is more or less how we have been publishing modern scientific research for a very long time. The system is imperfect, reviewers disagree, they make mistakes, they have biases. Occasionally a reviewer appears to be dealing with unresolved childhood trauma, but good peer review can genuinely improve a paper. And there is something quite elegant about the basic bargain. I review your research, someone else reviews mine. No invoices are required. The problem is that there is now much more to review. One analysis estimated that scientific article output in major databases was around 47% higher in 2022 than in 2016. That is an extraordinary increase in only 6 years. More papers mean more submissions mean more reviews. And rejected papers frequently move to another journal, where everybody receives another opportunity to review them again. There is now quite a good evidence that reviewer recruitment really has become harder. This certainly matches part of my own experience. When I send papers to or review for more selective journals, I do not notice this crisis very much. But when I worked as an editor for a large volume journal, finding reviewers could become an extraordinary exercise. You invite 5 people, nothing happens. Another 5, silence. Another 5, 1 agrees, and then eventually never submits the review. At some points the definition of appropriate review begins to evolve. Initially, is this person a respected authority in the field? Then has this person published something closely related? Then has this person published something vaguely related? Eventually it can feel a little like an airline that cannot find enough pilots and gradually changes the requirements from a licensed commercial pilot to has previously been on an airplane. I'm exaggerating, of course, slightly. Good journals generally protect reviewers' quality, but there is clearly a substantial part of the publishing system where finding qualified people willing to review has become a serious problem. Do we actually have too few reviewers? These scientists become just lazy? An interesting study tried to estimate the entire biomedical peer review workload. About 20% of researchers performed between 69 and 94% of the reviews. And there are many reasons why reviewing might concentrate among certain researchers. Editors know them, they publish frequently, they have established expertise, they appear in databases, they have reviewed before, so they get invited again and again and again. which raises another possibility. Perhaps we are not using the reviewer pool particularly efficiently. I noticed this very clearly in my own career. When I was a postdoc and later a junior researcher, I hardly ever received invitations to review papers. At the time, I actually wanted them. Then I became associate professor. I accumulated more papers as corresponding author, and suddenly the scientific publishing industry discovered that I existed. Now I receive too many invitations, but my eligibility to critically read a scientific paper did not suddenly appear the day of my promotion. There are plenty of experienced postdocs and PhD students in the final years of their training who would be perfectly capable of reviewing papers in the area they work on every day. In fact, for very specific experimental techniques, the postdoc doing the experiments by himself or herself may understand it considerably better than professor whose name appears at the end of the paper. And yet, journals tend to keep inviting the professor. BMC Biology, for example, currently advises editors that suitable reviewers should have at least 15 publications and ideally more than 10 papers in the past decade. That may be a reasonable proxy for experience, but it also excludes a lot of younger scientists who are perfectly capable of evaluating manuscript. So there is something slightly peculiar about the situation. We repeatedly invite the same established scientists, they become overloaded, then we conclude that the science has run out of reviewers, perhaps part of the shortage is self-inflicted then. But there is another uncomfortable possibility. Scientists do not accept review invitations randomly. They ration their time. Imagine I receive 4 invitations during a busy week. One comes from a leading journal in my field, the paper looks genuinely interesting. The second comes from a respectable journal, but it's a specialist journal. Third is vaguely related to my expertise, and the fourth comes from a journal I have never heard of, which appears to have been founded somewhere last Tuesday. I have time for one. This is not an especially difficult optimization problem. I will normally choose the most interesting paper from a more prestigious journal. Partly because I might learn something genuinely new from the unpublished study, and yes, also because it does not hurt if editors at good journals occasionally see your name attached to useful review. Scientists are human beings. Networking apparently survives peer review, but this produces an uncomfortable possibility. Suppose an editor contacts 15 scientists who genuinely understand the subject, and all 15 decline. Perhaps they are overloaded, perhaps the field is very specialized, perhaps the timing is bad, but perhaps the paper is simply not that interesting.
Boring!
Not wrong, not fraudulent, not technically inadequate, just not interesting enough that somebody wants to sacrifice an evening to read it. This possibility is strangely absent from discussions about the reviewer crisis. Every declined invitation is interpreted as evidence that the system lacks reviewing capacity. But sometimes it may also be a weak signal about the scientific attention. If nobody wants to read the paper before publication, perhaps we should at least entertain the possibility that not very many people will desperately want to read it afterwards. Obviously, you cannot use this to judge an individual paper. Reviewers' enthusiasm is not scientific quality score, but across millions of submissions, scientific attention probably tells us something. And perhaps we should be careful before building an entire system designed to override that signal. One often proposed solution is to remove the gate. Publish the research first, then let the scientific community discuss and review it afterwards. This sounds wonderfully democratic, and it has one minor problem. The scientific community generally does not bother. The NIH tried something remarkably close to this. In 2013, they launched PubMed Commons. Scientists could comment directly on papers indexed in PubMed. This was not some obscure website nobody visited, it was integrated in one of the central databases of biomedical research. Millions of researchers were already using it. No new journals were required, no subscriptions, no editor had to invite you. Just read the paper and comment. 4 years later, NIH shut it down. Comments had been submitted to around 6,000 articles. PubMed contains about 28 million. Apparently, when given the opportunity to review absolutely anything, scientists choose to review approximately nothing. which sounds like a devastating failure of post-publication peer review. But perhaps it is also telling us something else. Human attention is selective. Most papers simply do not generate enough interest for somebody to voluntarily critique them after publication. There is another increasingly popular solution: pay them. Show me the money! And this has obviously moral appeal. Scientific journals can make substantial amount of money. Authors provide the research, academic editors frequently help manage the papers, reviewers provide highly specialized labor, and reviewers are usually paid exactly zero. So the argument almost writes itself. If reviewing is work, pay people to do it. And unlike many attractive ideas in academic publishing, this one actually appears to work. A recent experiment at Biology Open used pre-contracted reviewers who received £220 per manuscript, providing that they complete the review on time and it met quality standards. Oh, £220? The British seem to have slightly confusing currency. Pounds of what? Tea? I always thought that it was unit of weight in countries where they do not know what kilogram is. Anyway, the results were impressive. Conventional review invitations were accepted around 23% of the time, paid invitations 67%. Completion among people who accepted rose from 87 to 98%. And average time to first decision with reviews fell from approximately 38 working days to 5.5. Review quality did not appear to decline, so paying reviewers is not a ridiculous idea. It works. And we already accept the principle elsewhere. Scientists are often compensated for participating in grant evaluation panels. We pay people to review grants, we pay people to review books, we pay people to review restaurants. Somehow, the restaurant reviewer has achieved stronger business model than professor evaluating cancer research. There is, however, one small administrative detail. Where does the money come from? Show me the money! Suppose two reviewers receive €250 each. That is 500 per reviewed manuscript. But journals reject papers. If 3 manuscripts need to be externally reviewed for every one eventually published, that is already 1,500 in reviewers' cost per published paper. The exact number is not important. The principle is somebody eventually pays. Perhaps a commercial publisher will simply accept permanent lower profit margins. This is certainly a theoretical possibility. There is also a theoretical possibility that I will one day be elected Bishop of Rome, but let us concentrate on economic models then, that do not depend entirely on miracles. If paid review becomes standard, I would expect much of the cost eventually to appear in fees paid by the authors, or subscriptions, institutional publishing agreements, or perhaps even submission fees. Publishers are extremely good at finding a customer for costs, and the customer in scientific publishing is usually science. So we could create beautiful circular economy. Universities pay scientists, scientists produce papers, university pays publishers to publish the papers, publishers pay scientists to review the other scientists' papers, publishers increase charges to recover the reviewer payments, universities pay those charges, the money leaves academia, visits the publisher, receives an invoice number, loses a certain percentage along the way, and comes home. We have solved unpaid peer review. Accounting departments everywhere can celebrate the additional transactions.
I am ready to get hurt again.
There is another issue. Today reviewing still works partly because of a social norm. I review papers because other scientists review mine. It is reciprocity. Not perfect reciprocity. There is no central spreadsheet ensuring that Professor Smith must review exactly 7.6 manuscripts because Professor Smith published 2.37 papers. But the principle exists. Once reviewing acquires a normal market price, the psychology changes. Suppose everybody knows that reviewing a manuscript is worth €250. The next unpaid invitation is no longer means only, would you please contribute to the scientific community? It also means, would you provide 250 worth of professional work for free? Maybe nothing changes, but perhaps fewer people then review voluntarily. More journals start paying and the market price becomes established. And paid reviewing gradually becomes the new norm. But I think there is an even more important problem. Paying reviewers converts reviewers' scarcity from a constraint into a cost. Today, if a journal wants to produce an enormous number of manuscripts, eventually it encounters a problem. Who the hell is going to review all of these? With the major paid review market, the answer becomes whoever we pay. And if the cost can ultimately be passed to authors or institutions, the constraint largely disappears. The journals can process more papers, authors pay more, reviewers get paid, the publisher continues publishing, everyone's immediate problem has been solved, except that now there are even more papers, and those papers become more expensive. Which brings us to a question that is surprisingly rarely asked. Why must every piece of scientific work become a peer-reviewed journal article? Academia has developed a peculiar convention. A project was performed, therefore a paper must emerge. A student needs PhD, paper. A dataset exists, paper. We validated what somebody already published, paper. We changed tiny detail in methodology, another paper. And I'm not saying this research should disappear, quite the opposite. Research findings should be accessible, data should be accessible, negative results can be useful, replications are useful, technical observations are useful, but publicly available and formally certified as peer-reviewed journal are not necessarily the same thing. We have preprints, repositories, data archives, protocols, technical reports, conference outputs, software repositories. The scientific results can exist. It can be searchable, it can be cited, it can be scrutinized without automatically requiring two anonymous experts to spend Saturday afternoon reviewing it. Yet universities, grants and scientific careers still strongly reward particular unit, the peer-reviewed paper. So naturally we manufacture a lot of them. Perhaps we need better reviewer matching. Almost certainly. Perhaps journals should stop sending obviously irrelevant automated invitations, definitely. Perhaps they should make much better use of experienced postdocs and advanced PhD students rather than repeatedly asking the same professors, also definitely. Perhaps reviewers deserve more recognition, probably, and in some situations paying reviewers may make perfect sense, yes. But if scientific community is producing manuscripts faster than scientists are willing to review them, then are two ways to interpret the problem. We need more reviewers, or we need fewer manuscripts requiring formal peer review. We almost always choose the first interpretation. Then we ask how improve reviewer matching, how to automate invitations, how to pay reviewers, how to use AI, how to process more manuscripts, but perhaps the bottleneck is trying to tell us something. We already publish more scientific papers than any individual researcher can realistically follow. Researchers now need search engines, systemic reviews, recommendation algorithms, and increasingly AI systems simply to determine which papers are worth reading. And meanwhile, we are worried that we cannot recruit enough humans to carefully evaluate every additional paper before adding it to a pile. There is something slightly circular about it. We are producing too much literature to read, and our solution is to create enough reviewing capacity so that we can produce even more literature. Traditional peer review is frustrating. It's inconsistent, it depends on unpaid work, sometimes it misses serious errors, sometimes it blocks good science, sometimes it produces excellent criticism that fundamentally improves the paper. It is not an especially beautiful system, but compared with the alternatives, it may still be one of the least bad systems we have. And free peer review is perhaps not quite the right description anyway. It's not free, scientists' time costs money. Universities, governments and charities are already paying our salaries while we perform those reviews. But a traditional system does not require a financial transaction every time somebody reads a manuscript. Its currency is mostly reciprocity. I review yours, somebody reviews mine. It is primitive, it is inefficient, and it has somehow kept a huge part of scientific quality control running for decades. Perhaps we should improve it without assuming that every friction in the system needs to disappear. Scientific attention is finite. That may actually be useful. If we cannot persuade enough scientists to read, evaluate, and discuss everything we want to turn into journal article, perhaps the solution is not automatically to manufacture more reviewing capacity. Maybe not everything needs to become a paper. Some research can simply be shared, some can be archived, some can become datasets, protocols, or technical reports. And some deserve the initial effort from peer review. The goal should not be to publish as many peer-reviewed papers the system can actually process. The goal is to produce useful science. Those two things are related, but they are not identical. So perhaps peer review really is in crisis. But before paying armies of professional reviewers, building AI reviewers, or redesigning the entire system, we should make sure we have diagnosed the right disease. The shortage of reviewers may be real, but the shortage exists only relative to how much reviewing we demand. And if that demand keeps increasing, because academia insists that almost every research output must eventually become another peer-reviewed paper, then perhaps the strangest solution would be to make the machine even better at producing them. Peer review may be slow, it may be annoying, it may depend on an absurd amount of voluntary work, but perhaps some of that friction is performing a useful function. If you enjoyed this tour through another completely irrational part of academia that becomes slightly irrational when everyone participates at once, please like and subscribe. And if you disagree, leave a comment. That would technically count as post-publication peer review, I guess, which already gives this video a better participation than PubMed Commons. Thank you for watching. Bye.